Alright, my name's David Nader.
I'm Robert Clapper.
I'm Mira Alanoli.
I'm Doug LaBranch.
And we are Lake
Lake
Canucks. What we did was we came up with the Bernoulli bucket for our project. It's pretty much a bucket from Home Depot with a piece of PVC pipe sticking out of it. But what's going to happen is we're going to fill this up with water, and there's a valve right here. We're going to open up that valve, and the water's going to flow out. And right here we have vinyl tubing at this point and then this point. And pretty much these two vinyl tubes right here are set up right at the surface of the pipe. So what that's going to do is that's going to measure the pressure head of the water. And then in this pipe and this pipe right here, we have one of these little elbows right here. It has the same diameter as the tubing, so it's in there pretty much just like that. And what that does is that pretty much measures the pressure head, plus there's going to be an additional velocity head because there's laminar flow. And on the outside, there's not going to be any velocity, but then in the middle, where this tube is, there will be. And what you're going to see is there's going to be a water level here, and then a water level here, and then this is going to be pressure head, and then this will be pressure head plus velocity head. And you'll see the same thing over here. But what's going to happen is the water levels here will be higher than the water levels here because there's going to be head loss between these two. I know the pipes kind of don't seem like they're at the same spot, but if you look at this, the elbow is pretty much where this tube would be, so we can, any loss there is negligible. So, yeah, that's our project. Want to get us ready? And what's going to happen is, as the water level goes down, you're actually going to see that the velocity head, which is pretty much the distance between these two lines, will start to decrease. And what we realized is that if you take a picture at any given point in time, the velocity head here is always going to equal the velocity head here, regardless of head loss, which is why we have the rulers there.
It's about 2 inches for our
head loss, yeah. And what happens is when the bucket was filled, when we did our math out, we realized the velocity head here was about, I think, 2.5 inches, and it was 2.5 inches here at any instant in time, and then at halfway full it was about an inch here, and then it was also an inch here. Okay, ready? And you'll see the differences right here is the velocity head, and it's the same, but the water levels here are less than the water levels there because they head loss. So we realized if we apply Newton's equation, this was the pressure head, this was the velocity head, and this was the distance from the atom. The Z1 and Z2 terms pretty much cancel out because it's on level ground. The velocity heads were the same at any point, so those canceled out. And so the only difference was the pressure heads, and then the difference in the pressure heads was the irreversible head loss, which we calculated to be 2 inches for every foot of piping. And that's our project.
so much for whipping nails.
It didn't work out as well as we thought it would.
Shouldn't we go get more?
Yeah, could you?